Hello folks, we are coming to the part 2 video and we are just going to continue with what we had done in the previous video. They give us certain events and we have tried the sample space. That's about it. I have just written it in abbreviated form. There are 3 dyes, red, white and blue color dye. You have to note the color and then the number. Let's see once again. One die of red color, white color and blue color are placed in a bag. You have to choose a die at random and then you have to note its color and then the number on the uppermost face. So you have this bag which has got these 3 dies. We will take one die at a time. We will note the color and then we will see what is the number on the die. That's about it. So maybe first time I have got a red. I can get a red, I can get a white or I can get a blue. So that's about the die. Then they ask us to note the number. Now number can be anything. So from the red I can get 1, from the red I can get 2, from the red I can get 3, I can get 4, I can get 5, I can get 6. Same way from the blue I can get 2, was it or was it black? Blue, yeah. You can have this, then from the white also you can have all these possibilities. That's what they're asking us to list. That first you note the number and then first you note the color, then you note the number. This is how we do it. This is the sample space. That's about it. Then we have the 8th question where this boy girl, it's a very famous problem. We had it in the 10th standard also. So there is a boy girl thing in the family and then the first subpart they are asking us to list a sample space where you have the boy or girl in that order. You know, how can it be like first boy, second girl, like that, what all things can happen. So that we will list first. So what all things can happen? First you can have the boy, then you can have a girl, or you can have a girl, then you can have a boy. Or sometimes you can have both girls, or sometimes you can have both boys. So these are the different possibilities whenever you have to list them in the order of their births. Then they are asking us in this sorry, in the second part they are asking us to list it as a sample space for the number of girls. Now number of girls, how you can have the sample space? That there is no girl, that there is one girl, that there is 2 girls. These are the only possibilities, right? In this sample space, what all things can happen? In terms of the number, you can have one girl, you can have no girl, you can have one girl, and you can have 2 girls. This is the sample space in terms of the number. They have asked us the number. That's about it. Then we go to the 9th problem where they say that there is 1 red ball and 3 identical white balls. Identical white ball means you cannot distinguish between them. You cannot call them as W1, W2, W3. You cannot call them because they look exactly same. So when you take it, you don't know which you have taken, right? So they have to be called only as W. So 2 balls are drawn without replacement. So from this particular collection, you are drawing 2 balls. You are not replacing. Once you have taken it, you have not kept it back. You are taking it and throwing it somewhere else, right? If that is the case, what all possibilities can come up, right? Now the white ball, though they are 3 in number, they are identical, means it's almost like 1, and it will do the effect only of 1. So first, what all are the possibilities? First I would have chosen a red ball, then I will choose a white ball. I don't know which white ball, but I would have chosen. Suppose they were different, then we could have written it as RW1, RW2, RW3, like that we could have written, but here we cannot distinguish, so we have taken a white ball. Or we have taken a white ball first, so we are left with an option of another white ball or a red ball. So I have taken the first white ball, I am taking the next red ball, or I have taken the first white ball, I am taking another white ball again, right? So these are the only 3 possibilities. Why? Because they are identical. If, as I said, if it was not identical, we would have put the suffix 1 and we would have listed the sample space would have expanded. That's about this, right? Now 10th problem, though I have written it in shortcut form, I will also read it so that it's very clear to us. 10th problem says that an experiment consists of tossing a coin. We are tossing a coin, head, tail. Yeah. We will first toss a coin, it will give you head and tail. Then throwing it a second time if the head occurs. Only if the head occurs, you will throw it once more, so that you will again get head, tail. So if the tail occurs in the first toss, then a die is rolled. But at the same time, suppose if a tail occurs, then you roll a die. Die means 1, 2, 3, 4, 5, 6. So that way. So what do they ask us? find the sample space. So first they say, in some cases they are a little fussy. First list the color, then do that. First list whether it is head or tail, then they're not told that. They've only asked us to list the whole thing. So first time we consider that we have got a head. So it's very clearly given that if it's a head, then you're tossing a coin again. So the moment I've got a head, I am tossing a coin again. So I can get a head or I can get a tail. So I would have got a head or I would have got a tail. Those are the two possibilities. But suppose if I would have got a tail, then I am asked to roll a die. So when I roll a die, I can get any number from 1 to 6. So it could be like T1 or it could be like T2 or it could be like T3, T4, T5 and T6. Right, that's a possibility, right? Let's quickly go to the third problem. Now third problem also I will read it out, though I have written it in abbreviated form there. Suppose say 3 bulbs are selected from a lot of bulbs. There is maybe a box or something which has got lots of bulbs. From there you are choosing 3 bulbs. Each bulb is tested and classified as defective or non-defective. Write a sample space for this. Now these 3 bulbs that you have chosen, it could be like anything. Either that there is no defective, or that there is 1 defective, or that there is 2 defective, or there is all defective, like like no defective, 1 defective, 2 defective, 3 defective, right? Almost like our case of 3 coins being tossed and we are finding out the possibility of head. It's almost like that. So let's take the case where D is called as defective and N is called as non-defective. We will list the possibility. So we have no defective, means all are good. So non-defective. 1 defective. So 1 defective. Then 2 defective. Then 3 defective. That's it, right? Like how we did the case where we were doing the tossing of the coin. We were taking the head case and doing. So almost like that. Okay, that finishes our 11th problem. 12th problem says that, I'll also read that problem as we did before problems, the earlier problems. A coin is tossed. Okay, if the outcome is a head, when the coin is tossed, if the outcome is a head, then you throw a die. 1, 2, 3, 4, 5. So you're throwing a die. If the die happens to be an even number, what it say? If the die shows an even number, then a die is thrown again. Again 1, 2, 3, 4, 5. What is the sample space? So only certain possibilities are listed. So first of all, a coin is tossed. So you will get a head or you will get a tail. So because tail is hassle free, first we'll write the tail. Then we are tossing. Suppose say we are getting a head. You can get an even number, you can get an odd number. Suppose say you get an odd number, you just stop your experiment and go away. Okay, only for even number they have given us the cases. So odd numbers, if I get H1, if I get H3, if I get H5, if I get, I stop my experiment and go off. But if I get an even number, then I am supposed to again throw a die. So suppose I have got an even number H2. Then I have to throw a die. So that will give me any number. I can get H21, I can get H22, I can get H23, I can get H24, I can get H25, then I can get H26. Even for the other numbers, H41, H42 and so on, H46, same way H61, H62 and so on, H66. That's it. They have left the tail, they have left from this, and they have also left the tail they have left, and they have also left the odd numbers. Only even numbers they have put a condition that you have to do it again, and this is your sample space for those even numbers. You are getting this H42 and so on, H66 and all that. So that's about our this video, part 2 video with these many problems. Remaining problems will come in the next video. Thank you.